Welcome to this expert technical training module. Today, we are undertaking a deep dive into the critical considerations for privacy and security within the responsible AI framework. Welcome to this comprehensive technical deep dive into responsible AI, where we will rigorously examine the critical considerations for privacy and security within artificial intelligence solutions. As AI models become increasingly sophisticated and integrated into enterprise workflows, the data they consume and generate requires unprecedented levels of protection. The fundamental reality of modern AI development is that machine learning models are trained using colossal datasets, and these datasets frequently contain highly sensitive personal or organizational information. As an AI developer, architect, or data scientist, you carry a profound ethical and technical responsibility to ensure that this training data is kept absolutely secure throughout the entire machine learning lifecycle. But the responsibility does not stop at the training phase. You must also implement rigorous architectural safeguards to ensure that the trained, deployed models themselves cannot be manipulated or exploited to reveal private, personal details or proprietary organizational secrets to unauthorized users. Privacy and security constitute a non-negotiable pillar within Microsoft's broader responsible AI framework, standing alongside fairness, reliability, inclusiveness, transparency, and accountability. Without robust privacy controls, an AI system immediately compromises user trust and violates regulatory compliance standards. In this session, we will break down the mechanics of securing your AI ecosystem, from data minimization techniques to identity management, secret protection, and automated data redaction. We will explore how Azure's native security infrastructure empowers you to build formidable defenses around your AI applications, ensuring that intelligent systems respect data boundaries and operate securely by design. While there is no specific application logic to execute here, privacy and security must be treated as code-level architectural requirements. Developers must translate these responsible AI concepts into programmatic guardrails, integrating strict encryption, identity checks, and data validation directly into the deployment pipelines to guarantee the system maintains absolute data confidentiality. Examine the flowchart on your screen. This diagram illustrates the end-to-end security posture required for AI development. Raw training data is immediately subjected to security controls before entering the secure training environment. To practically apply privacy and security principles, we must first address how data is handled, specifically focusing on data minimization and strict lifecycle management. A prime example highlighted in our training materials involves a facial identification system deployed in an airport or another highly secure physical environment. In this scenario, the AI application captures biometric data, specifically facial images, to grant individuals temporary access to restricted areas. According to the foundational principles of responsible AI, the system architecture must be explicitly programmed to delete these personal images the absolute microsecond they are no longer required for that specific, temporary access event. Retaining this highly sensitive biometric data longer than functionally necessary creates a massive, unjustified privacy risk for the organization. Furthermore, the system must incorporate aggressive access control safeguards to prevent these images from being made accessible to human operators, database administrators, or any users who have no legitimate, immediate operational need to view them. This scenario perfectly illustrates the core tenets of privacy in enterprise AI. Collect only the data you absolutely need, use it exclusively for its strictly intended purpose, restrict visibility to the absolute minimum number of authorized entities, and completely destroy the data immediately after its utility expires. By engineering your AI applications to automatically purge transient data and strictly limit exposure, you drastically reduce the potential attack surface. This proactive approach to data lifecycle management is the most effective defense against data breaches and unauthorized surveillance, ensuring your AI solutions remain ethically sound and technically secure. In a software environment handling sensitive temporary data, your code must implement automated deletion routines. For instance, after a successful biometric authentication event, the API processing the image should explicitly call a deletion function to wipe the image binary from blob storage in memory, ensuring no residual data traces are left behind for potential exploitation. This visual demonstrates the critical path of transient data processing. Notice how the biometric capture flows into the AI inference engine for authentication. Regardless of whether access is granted or denied, the absolute next required step is immediate automated data deletion. Securing the underlying data is only one half of the equation. We must also aggressively secure the cloud infrastructure that hosts the AI application itself. AI applications process immense computational workloads and require formidable protection alongside highly stable network connectivity to function safely in enterprise environments. Because Microsoft Azure is inherently secure by design, it provides the foundational tools necessary to achieve this, specifically through built-in identity management, rigorous access control, and strict network isolation. At the very heart of this security architecture is Microsoft Entra ID. As an AI developer or solutions architect, you rely on Entra ID to ensure that only the right, explicitly authenticated people and approved software services can interact with your valuable AI resources. Entra ID enables the implementation of role-based access control, commonly referred to as RBAC. With RBAC, you can surgically limit access permissions to specific model deployments, back-end storage databases, and AI compute clusters. For instance, a junior developer might have read-only permission to view model evaluation metrics, but zero permission to modify the production endpoint or access raw training data. Coupled with network isolation, which physically and logically separates your critical AI workloads from the public internet using virtual networks and private endpoints, these identity controls form an impenetrable barrier around your AI solution. By leveraging Microsoft Entra ID and RBAC, you strictly enforce the principle of least privilege, guaranteeing that every interaction with your AI system is explicitly authenticated, heavily monitored, and strictly confined. From an infrastructure as code perspective, implementing RBAC means writing precise resource manager templates. When deploying an AI resource, your configuration scripts explicitly define role assignments, mapping specific user groups or managed application identities to predefined Azure roles. This code-driven governance guarantees that network isolation and access restrictions are consistently applied across all environments. The diagram displays a deeply secured infrastructure boundary. An external user or app must first pass through Microsoft Entra ID. If authenticated, the request is then evaluated by an RBAC policy check. Moving deeper into application-level security, we must critically evaluate exactly how our AI code interacts with external services and protected model endpoints. To connect to an AI service, your application uses an application programming interface, or API, and authenticates using a highly sensitive credential, such as an API key. A secret is defined as any sensitive value that grants programmatic access to a system, service, or underlying database. The absolute golden rule of AI security engineering is this: you must never, under any circumstances, store these secrets directly in your application's source code or push them to a version control system like GitHub. Hard-coded secrets are easily compromised by bad actors and represent a catastrophic security vulnerability for the entire organization. Instead, Azure protects an AI application's credentials by utilizing Azure Key Vault. Azure Key Vault is a highly secure, centralized cloud service designed specifically for safeguarding cryptographic keys, passwords, and API tokens. The correct, enterprise-grade architecture involves storing your AI endpoint keys exclusively inside the Key Vault. Your application then utilizes a managed identity, an automatically managed, passwordless identity in Microsoft Entra ID to securely request and retrieve the required secret from the Key Vault dynamically at runtime. This process happens seamlessly in memory, completely eliminating the risk of exposing the key in plain text files or configuration scripts. This robust secret management architecture is absolutely vital for maintaining privacy. To retrieve a secret dynamically, your Python code utilizes the default Azure credential class from the Azure Identity Library. The code requests the secret from the Key Vault URI using the secret client. Because the application runs under a managed identity, it authenticates silently without needing a hard-coded password. The retrieved secret is then held temporarily in a variable to authorize the AI client object. This logic flow illustrates the secure secret retrieval process. The AI client application leverages a managed identity to seamlessly authenticate with Azure Key Vault. The Key Vault safely returns the API key directly into application memory. The application then uses that dynamic key to securely authenticate with the Microsoft Foundry endpoint, executing inference without ever exposing hard-coded credentials. As we shift our focus from infrastructure mechanisms to natural language processing capabilities, we encounter the massive challenge of handling sensitive user input safely. When end users interact with conversational AI agents, they frequently, and often inadvertently, submit highly private information in their prompts. To rigorously uphold the privacy pillar of responsible AI, developers must actively scan and sanitize this input. This is achieved through personally identifiable information, or PII, detection. PII detection is an advanced AI capability that automatically identifies sensitive personal details hidden within unstructured text blocks, such as full names, personal phone numbers, private email addresses, financial account details, and street addresses. By integrating tools like the Azure Language SDK, developers can programmatically route incoming conversational text through a PII recognition engine before that text is logged, stored in a backend database, or used to fine-tune future language models. Crucially, this service does not merely detect the sensitive entities, it can automatically redact them, replacing a real phone number or physical address with an anonymized, generic placeholder. This automated redaction step is absolutely critical for maintaining regulatory compliance and safeguarding user privacy. If your enterprise application records customer support transcripts or analyzes user feedback, injecting a strict PII detection and redaction layer ensures that your organization never inadvertently hoards restricted personal data, neutralizing privacy risks. Implementing PII redaction involves calling the recognize_PII_entities method from the Azure Language Client Library. Your code passes the raw user text to the service, which returns a structured response containing both the categorized entities and a fully redacted string version. Your application logic must be programmed to instantly discard the raw input and strictly log or process only the redacted output payload. Observe the data sanitization pipeline on the screen. Raw unstructured user text flows directly into the Azure Language PII detector. The system actively identifies sensitive entities, extracting details like names, addresses, and financial data. It then applies automated redaction to these elements, producing a completely sanitized output that is perfectly safe for long-term logging and analytical processing. Another highly critical dimension of AI privacy emerges when building advanced AI agents that utilize retrieval augmented generation, commonly known as RAG. These sophisticated agents are specifically designed to pull contextual information from your organization's internal document stores to answer user queries accurately. However, a major security catastrophe occurs if an agent retrieves, summarizes, and outputs a highly confidential executive document to a user who does not legally possess the clearance to read that document. To actively prevent this, enterprise AI solutions must utilize permission-aware knowledge architectures, such as Microsoft Foundry IQ. When an AI agent queries a multi-source knowledge base in this environment, the retrieval system does not blindly access and scrape all index data. Instead, it natively enforces user permissions and actively respects Microsoft Purview sensitivity labels at the core infrastructure level. This means the underlying vector search index continuously cross-references the verified identity of the user asking the question against the strict access control lists of the source documents. The retrieval engine will only extract and return information that the specific user is explicitly authorized to view in the underlying systems, like SharePoint or blob storage. By implementing strict, identity-driven access controls directly at the retrieval layer, organizations guarantee absolute internal data privacy. When configuring a knowledge connection in Foundry, the underlying architecture maps the querying user's Entra ID token to the data source's access control list. From a development standpoint, you do not need to write complex permission filtering algorithms in your application code. Instead, you pass the authenticated user's context to the agent SDK, and the Foundry IQ layer securely handles the permission evaluation during retrieval. This diagram showcases the secure RAG workflow. A user query via an agent enters the Foundry IQ retrieval engine. The engine immediately cross-references the user's Entra ID and checks Purview sensitivity labels on the source files. Only authorized content is extracted and sent to the language model, resulting in a secure, grounded AI response that perfectly maintains internal data privacy. As we conclude our intensive deep dive into the privacy and security considerations of responsible AI, we must adamantly emphasize the overarching principle of accountability. Ultimately, the people, the developers, and the organizations that design, train, and distribute AI solutions are fully, ethically, and legally accountable for the security of their systems and the privacy of their end users. You simply cannot outsource ethics or security to a machine learning model. Because of this reality, it is absolutely imperative for organizations to define, implement, and rigorously audit a strict, comprehensive framework of governance. This governance framework must explicitly dictate exactly how data is sourced, how sensitive PII is continuously redacted, how cryptographic secrets are managed via Key Vault, and how RBAC is aggressively enforced across the entire AI software development lifecycle. Furthermore, organizations must practice absolute transparency, clearly disclosing the use of AI to consumers and describing the nature of the data it processes, while simultaneously protecting confidential intellectual property. We hope this expert-level training has equipped you with the technical strategies required to secure your AI architectures. If you found this video valuable, please like, subscribe, and share it with your peers. To truly master these critical concepts and accelerate your career, visit quicktechie.com for our premium certification prep materials. Quicktechie.com offers comprehensive Q&A banks, detailed ebooks, audiobooks, advanced training modules, and expert interview guides designed to make you an industry leader. Build securely, innovate responsibly, and we will see you in the next lesson. Accountability and technical execution requires comprehensive audit logging. Your application code must persistently log all authentication events, PII redaction triggers, and authorization failures into a secure, immutable storage solution like Azure Monitor. These programmatic audit trails provide the undeniable forensic evidence required to prove to regulators that your organizational governance framework is actively succeeding. Our final flowchart visualizes organizational accountability. It begins with corporate leadership defining an AI governance framework. This framework actively enforces Key Vault and RBAC implementation while mandating PII redaction pipelines.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.